Welcome to day 13 of the Advent of Code 2022 in Rust. Today we're dealing with a distress signal. So we've received a signal from the elves, but it's out of order, and we're trying to reorder the packets we've received. So we're given pairs of lines as inputs. Each one is a packet, and we've got to decide whether or not they're in order. So they are lists of numbers, or they are nested lists of numbers, or they can even be empty lists or just single numbers on their own. And then you can see we get some funky stuff like nested empty lists. So we're given some rules. So if we've got two numbers we're comparing, the lower number should come first. So if it does, the lists are in order. If it doesn't, the lists are out of order. The same with lists. We can compare them by comparing their values. If one list runs out before the other, then we care about the left list running out first. That's in order. Right list running out first. They're out of order. And then finally, if one value is a number, we convert that number to a list and then compare it with the other value as a list. So quite a bit of logic required, and we're given a work-through of an example, and then we're asked to calculate, okay, find the pairs that are in order already, find their index, and sum those indexes up. So let's jump in. I've started with most of the code written today, because a large part of the problem is parsing, and then writing a lot of match statements. So I've started with an enum that can either be empty, so representing an empty list, or a number, or a delayed expansion. So that's when we have a sublist. So let's have a look at how the parser works. So the parser will work through an input string. It will look for start of list. If it finds one, it just scans ahead looking for the closing bracket that matches that, and it'll keep track of how deep it's gone. So if there are multiple lists, we'll gloss right over all the nested ones, just pull out the end of that list that we're trying to scan for. And that becomes a delayed expansion, so we'd parse that next if we need to. If we find the end, we're done. If we find a comma, we skip it. Anything else must be a number. So we try and parse that number and push it back into our parse result. So the output will be an iterator over enums of this parsed item type. So that's our parser. The next thing to do is to pass off our input strings, the left and right strings, which is how the problem refers to the pair of packets. Left is the top one, right is the bottom one. And we try and determine order based on that. So we run through the iterators for the left and right. We've got the case that both of them have a value, in which case we handle all the possible cases of values. Or one of them has finished and the other hasn't. If we get to the end of both of them, we can't make a decision, so we return none. And that shouldn't happen at the top level, because our input should give us a result for every pair, but that will happen if we go down a level and we use this function recursively. So we call it, if there's a case where we have, for example, two delayed items, so two sublists, then we parse both left and right and try and compare them. If we can, we return a value, otherwise we'll continue with the iterator at the current level. So Rust makes this really nice because we've got optional values coming back from our iterators. We know if we got a result, we know when we finished our list, and we know that we've covered all the cases for combinations of number, empty, and delayed, because otherwise this wouldn't compile if we had missed a case here. So let's go ahead and run this now and have a look at what the output looks like for the parse function. Okay, we can cargo run that with the sample input. That's the input from the problem. And you can see the first pair of lines are coming out something like what you see on the website, which is a series of numbers compared with a series of numbers. And in the third position, we'll have a difference between the 3 and the 5, which will tell us whether these are in order. And then for values that have sublists, we've got the sublist not parsed yet. So we've got a delayed list of 1 and a delayed list of 2, 3, 4, and so on. So that is our parsed output. Now we've already got the logic built for comparing the order of two packets. So all we need to do is figure out how many packets are in order and what indexes they're at. So let's build that bit now. What we've got here is the input lines all red, the empty lines filtered out, and then broken down into pairs of 2. So each item in this iterator is a packet. So we can start by enumerating the packets, because it's the packet indexes we're after. Enumerate. Then we can map, and that will give us back an index and a pair of left-right packets. Then if is in order, or in order even, of left and right, and we'll unwrap that value. Then we want to keep track of this index, which is 0 base, so we want to return value 1 because the problem's asking us for 1 based indexes. Otherwise, 0. Then we can sum those up, and that will be our result for part 1. And we can print that out. Let's have a look. We'll run it with the sample input first, just to make sure everything's working. So that's coming back with 13, which is what we're after. That's good. Let's run it on the real input then. So that's coming back and saying 5013. So let's see if that's the right answer. So is that right? Certainly is. On to part 2 then. Part 2 is asking us to work our machines hard. So we're going to take the same set of packets we had before and add these 2 new divider packets, which are these list6 and list2. We'll then sort the entire set of packets, which we can do because in part 1 we built a pairwise comparison between 2 packets. So we can tell the sorter algorithm what that comparison is, and it will be able to sort our list for us. Then once we've got everything sorted, we've got to come and look for the 2 divider packets in our set, and wherever those are, we find the indexes of them. We multiply those 2 indexes together to get our decoder key for our distress signal. So let's get started. I've started by loading a new copy of our input file because we're going to want it in a different format, and I'll tidy up the difference with the array chunks before I check this in. So let's collect those down into a vector. So packets becomes a vector of string, and let's make it mutable. Then we can add in the 2 packets that we're required to check for. So we can do packets.push, and that'll be 2 and 6. There we go. And then we can sort our entire set. So we can do a sort by, and that takes a function which takes a left and a right value. And then we need to say if they are in order, left toString to copy it. There we go. So if they're in order, we can't return true false from this. What we want to return is an ordering. So we'll do ordering, and if the left is in order, that means it's less than the right. So we'll say less, otherwise greater. And we haven't got to worry about checking whether these things are equal. That's one of the other possibilities for this ordering enum, because we know that our equality never happens. So we've already run through our whole input and unwrapped every item from it. So if we'd had any values that were equal, we'd already have errored, so that's fine. We haven't got to worry about that. So that's now going to sort our packets in place. Then we can figure out what our final value is. So we can take our packets, we can turn that into an iterator. We can enumerate that because we're going to want indexes. Filter it to find the packets we care about. So that will take a function which takes an index that we can discard for now. Let's move this down the screen. And a packet. So if that packet matches 2 or that packet matches 6, then we want to keep it. Then we can map to get out the index that we care about, and we can throw away the other value, we don't care about that. And that will be index plus 1 because it's 1 based. And then we can compute a product of those numbers, so multiply them together. So that will be our part 2 result. And that will be a usize. We're multiplying together 2 values from an enumerate, which are usizes. Finally, we can print that out. Part 2 result. So let's run that with the sample input and see what it says. All right, let's kick that off with the sample input. And we've made a mistake. So our in order returns an option, not a single value. So let's do exactly what it's suggesting. We want the as sum. Or actually, we do care about the true false value here. So it's not just whether it contains something. So let's actually unwrap that. That does matter. Okay, let's run that again now. Okay, so that should run now. And it does. So it's saying the answer to part 2 is 140, which matches what the puzzle sample answer is. So let's run that with our input and see what we get. Okay, so not too bad on the speed front, saying about 54 milliseconds. So could definitely be faster, but not terrible. And it's giving us an answer of 25,038. So let's see if that's the right answer. Okay, let's give it a check. Fantastic. 13 days down, over halfway now. So I'll be doing tomorrow's puzzle, and then I'm away on Thursday. So I'll be delaying the puzzle one day for Friday. So you'll get 2 on Friday. See you tomorrow for the next problem.